Hi everyone, I hope I'm audible and perfectly visible. A very good evening to all of the guys present here. And in today's session, we'll be doing a quick recap for the IP addresses and then we will start the subnetting part. So we'll start in a minute. Okay, just please comment down if I'm visible or not, like or visible or audible both. Okay, just please comment down. Good evening, Jayant. Good evening, Time Pass Boy. Good evening, Aniket. Hello, visible and audible. Good evening, Daksha. Good evening, Guru. Hi. Perfect, guys. We'll start in a minute. Okay, so we'll start today's session and just give me a minute. I'll just open the comment section. Okay, live training. Just a second. CCNA. We have the video ID. Okay, so let us start today's session, and we have 20 people here. Admin was removed. I went out in yesterday's class. Last event is for B for this and for medium buildings. Why don't we include 127? Yeah, so the 127 IP is basically a loopback IP, or we can say IP which is used for the local host. As if you are into development part or something, or if you have ever used VS Studio or developed any of your websites, so we use this IP to like it's for our local use. So in today's session, we'll give a recap, scanning, a quick recap and some new things about the IPs. Okay, home safe, home safe. place to test. Yeah. Okay, so we have two things here. First of all, binary and decimals. Any of you guys have idea what is a binary and what is decimals? Because it is quite important to understand this basic math. Hello, Lilith. I didn't understand this. Binary. Yes, 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 yes. Okay. So, for example, binary and decimals. Decimals are basically binaries and zeros and ones, and decimals are basically numbers which are human readable or humans can read those numbers, right? And decimal 0 to 9. Okay. Human readable numbers, right? So, binary, for example, we take an example called uh no, for first let's just cover the decimals. Decimals and for decimals, for example, I take an example like 1650 or something like that. Okay. Now, how basically it is being understood, I'll just have to minimize the opacity of this. Okay. So it is like basically, for example, zero. So it goes, it is basically the, if you want to understand, so it has just a power of 10. Okay. For example, it can be the number we have used here. It would be 10 to the up power was power, the power 3, then 10 to the power 2, then 10 to the power 1, and we start from the right side, so that's quite opposite, and 10 to the power 0. Okay, so this is how we understand the decimals. Okay, how human understand the decimals. And now, next thing we have here is binary. So binary are the things which computers understand. Okay, so example can be zeros and ones. Okay, it is basically being understood in zeros and ones. Like it can example would be 1 1 1 1 1 1 1 or something like that, or it would be 0 1 1 0 0 1 1 0 something like that. Anything. Okay. So it can be example of binary and it works on the power of 2. Like the power is basically the up part and something like that. And now we'll learn how to convert a decimal, sorry, a binary to a decimal. And we'll just take a easy example here. Yeah, so we just got to know that binary may we have power of 2. Okay. So what I'll do here is I'll just if you didn't get or if you didn't understand this basic decimal or binary, you can just have a or watch a YouTube lecture and like a simple lecture with basically you it might be possible you are not good at maths. Okay. So 2 to the power 0 and this would be 2 to the power 1. This would be 2 to the power 2. And this would be 2 to the power 2 to the power 3. Got it. Now, if we move further and if we just classify this thing, so it would be written as 2 to the power 0 into the binary we have. We have 1 here, so we'll write down 1. And second thing here, 2 to the power 1 into the binary which is written here is 0. Third thing here, 2 to the power 2 into the binary written here is 0, and here 2 to the power 3 into the binary written here is 1. Okay. Now I'll just classify it bit more and we'll understand. Yeah. So 2 to the power, if anything, is divided by what is the answer for this one? This part? 2 to the power 0 into 1. What would be the answer? It would be 1, right? 1. Okay. And if 2 into 0, it's 0. If anything is multiplied by 0, it's 0. And 2 to the power 3 is 8. Okay. Into 1. Now what we have to do is we'll just have to add these numbers and the final result is 9. So this binary is converted, or we can say this binary is a decimal equivalent. I can write this term decimal equivalent for this thing. Okay, this binary. Now, we'll go further. We'll do one thing here. Just this is the yesterday's topic. Okay, so we have one thing here. For example, 1, 2, 3, 4, 5, 6, 7, and 8. And these eight, we can say these eight binaries, or this is a set basically, eight binaries is equals to 1 byte, or we can say 8 bits. Okay, 8 bits equals to 1 byte. I can just write it down that 8 bits is equals to 1 byte. We already, like most of you guys already know this thing. Now, and we know that 8 bits is equals to 1 octet, right? We are already done with this thing. Or we can say 1 byte is equals to like 1 octet, right? Correct. And the range here, as we know, binary works with the power of 2. So the range would be, it can be 2 to the power 0 to 2 to the power 8, right? And what would be the answer? And what would be the answer for this? Like, what is the actual range here? 255. Okay. Not 255. It's not 255. 2 to the power 0 is equals to 1, right? 2 to the power 0 equals to, I'll just break it down for you guys. 2 to the power 0 equals to 1. 2 to the power 1 equals to 2. 2 to the power 3 equals to 4. 2 to the power 4 equals to 8. Okay, 3, 2, 4, 6, 8, and then we have 2 to the power. Okay, I wrote it down. Just okay, I forgot 2, and this is 3, and then we have 2 to the power 4 is equals to 16. Then we have 2 to the power 5 is equals to 32. Then 2 to the power 6 equals to 64. Then further 7, further we have 8, and 8 is basically 256. And we have this thing here, so 128. This is the basic breakdown, and range basically here is 256. Okay, and I'll just move further. Yeah, 1 to 256. Okay, perfect. Now we'll move further. With the next thing, the recap we just have to complete. That is for the what is IPv4? Okay, so we were talking about IP addresses, right? So this is how a IP address or IPv4 looks like, and the dots here. Okay, this is basically divided by the dotted decimals. We have four period or four dots here. Okay. Now I'll just tell you one thing. This thing, whole thing, is a 32-bit binary, right? And we know that we have four octets here. As we know what are octets, so we have four octets here, right? And we know that one octet, octet is equals to 8 bits. Yeah. So one octet is equals to 8 bit, then four octet is equals to 4 equals to 32. Perfect. We have 4 into 8. 8 fours are 32. So this is the basic understanding of the or basic what we call it, background or breakdown for the 32-bit binary thing here. Are we clear with this? And then we'll move with the next part. The next part here is I'll just write down an example for our 12.44. Okay, so this is an basic example for the IP address. This is an basic IP version 4. And now what I'll do here is I'll just make it a line. And can you guys just tell me, we have two parts here for this. Any idea? We are already done with those parts. First one was we have two parts. Please comment down the name of the parts we have. Network and host. Perfect. Who's this? Nashra. Very good. Okay. So we have its network. NETW. I'll just write it down like NW. Okay. Network ID. And second ID we have is host ID or network part or host part, whatever you guys wanna say. Okay. Network ID and host ID. ठीक है. So अब देखो, how any of you guys can tell me how you will understand that what is the network part in this, and like which part is network part, which part is host part. For example, I just make a this thing here, and I'll just make a line here. Array, one, two, three, and the fourth one. Okay. So, for example, we have a random IP. We have an IP like 192 dot okay, I'll just we will be using the above example here. So how will you guys understand this is network part, this is host part, and like how will you identify that which IP is consisting the network past, or might be possible this might be a host part, or this might be a network part, anything, right? And this might be a network part, host part, whatever it is, right? So one guy said, okay, Aniket said using class for knowing which, using classes for knowing which are network part and which are host part. Perfect. By classes, nature level. Perfect. Starting 888 bits are network part and the last 8 are host part. Okay. Is it like time pass boy? Is it for every single case? Like 888 are for network part and the last 8 are for host part? Or you are just talking about this scenario? For example, if I give you another IP address, so would you just tell me that which is not network and which is host? We have 41 people here and 20 likes, so I would request you. No, not for all. No for class C. No, not for every case. Okay, I was asking time pass boy for this one. Okay, perfect, 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 perfect. Let's move further. Let's move further. That's great that you guys already know about the network ID and host ID. Yeah. So I'll just repeat the classes thing again. Okay, in a very simple way. So we'll just cover three classes A, B, and C. Okay. So we'll just give a quick recap. A, I'll just down class A. Class A uh, ranges from the range for the class A. Guys, comment down the range for the class A. Please comment down the range we have for class A. 1 to 126. Perfect. Okay. 1 to 126. Now, if I just write it down that, then we have the remaining things. Okay. Now, okay. Now, if we talk about the length here, length, length. I just said, okay, select, yeah. Length would be 8, and how will it be divided? It will be divided as first part would be our network, and remaining are host, host, and host. As we already know that this is how it is divided, and to identify that, okay. So this is the breakdown for the class A, and to identify this thing, you can just do a 2 to the power 8, like 2 to the power 8, 2 to the power 8, 2 to the power 8 for the three times. Okay. Now, you just have to remember one thing here. That is, you can even remember, or you can just do the calculations here. So, number of number of host for the class A. So, we have actually 16 million hosts for the class A. Okay, like we can cover basically 16 million hosts, or we can use 16 million. So as we already know, what can you guys just comment down what is the purpose of the class A IPs? Any idea? Okay, I'll just print off this. So I just use a period, okay, to N represents network and H represents host, governments or big organizations. Okay. Okay, okay. Then second thing we have is class B. Class B goes from or ranges from which one? For large networks, for governments, for organizations. Perfect, guys. And then we'll move to the class B. So class B ranges from class A IP is to support very large networks by providing a huge number of device address. Very good. 128 to 191. Okay. And the remaining are the things we have. Okay. So the length here network length, or we can say the length, Length, length here would be 16, and the network and the host would be N. First part would be network, second part would be network, and the remaining two parts are. Can you just comment down, or Aniket, can you guys just comment down how this 16 thing, or how this 8, the network length came, or people who know how this 16-bit or 8-bit came? I'd love to know that. Okay, so I'll continue, and we have number of HOSTS. They are around 65,000, 65,534. Okay. 16 bits network ID and 26. Okay. I just want to know the reason how, like, from where the word, or from where the term 16 came. I'm asking from two people here who uh, wrote the comment, Aniket and Jayant. Then we'll move to the next IP here. No, not to know, like, then why you wrote the 16 thing, like, from where the 16 thing came. Okay, so class B is basically a middle-sized or medium-sized network or class. So we have 65,000 host here, and it can be used for universities. It can be used for our hospitals, middle-sized hospitals. Okay, or some startups or some small companies, small corporations, not corporations, but companies. Okay, okay. I wanna know the range for the class C. Please comment down the range for the class C IP. We have 48 people here. I mean that it's structure but not know. Okay. Octet के वजह से है तो आया ना for network. 192 to 223. 192 to 223 for the class C, and the remaining is our the remaining IP address. Okay. Now here the length, Aniket, the length here. Aniket, or we have Rishabh, length 24. Perfect. So now, how can you identify that? Like, I mean, how many hosts would be there? So we have three network parts and a single host part. Okay. Now, number of hosts would be, अब यहाँ पे you'll just do a calculation here. So 2 to the power 24, and we just have to do something like sort of minus thing here, and it would be how many hosts? 256 hosts. Perfect. Got it. And yeah, one more thing I just wanted to mention here. Like, some people are saying 254, 254. So I'll just tell you how 254 came. Okay. So I'll just write down 254. And what I'll do here is, for example, I'll just create a box, and 254. All the first and last are reserved. Perfect. First IP and last IP is reserved. So the first IP is reserved for, it's basically a network ID, and second is reserved for the first is for network and second is for anyone? If you guys know, second one is for broadcast. Perfect. BROD cast. Broadcast. BROAD. Broadcasting is basically, we can say कि if you want to broadcast anything in all the devices, so you can use this last IP we have. That is okay. So the usable host here we have is 254, right? Okay. So if we are done, then we'll just move to the next step, that is send packets to all devices. Perfect. So we'll just understand the basic understanding of the IP version 4 and IP version 6. So we are already clear with the version 4, but version 6 was pending. So the definition here, or the I'll just show you an example. So IP version 6 is basically the newer internet protocol, and it uses 128-bit addresses, 128-bit, allowing for a virtually unlimited number of addresses. Okay, now I'll just show you IPv6 example. You can see this is how IP version 6 look alike. And each one, we have 128 bits here, and each section is of 16 bit, 16 bit, 16 bit. Got it? Network 0, host 1, 255, and 8 octets. Okay. Yeah. So this actually IP version 6 is rep I'll just copy an example here. 6. Okay, this can be example. We have an example here, and it is represented in 4, 5, 6, 7, 8, 8 groups, and of 16 bits each. As we have seen that 16 bits, each group is of 16 bits, and each group is written with written as hexadecimal, like 4 hexadecimals. 4 hexadecimal digits. Okay, and this IPv6 is quite huge. Quite, matlab, it is very, very, very huge, and like you can say unlimited, like literally unlimited number of addresses, right? No classes defined. Okay. As for today's session, I actually don't have an PPT, and I just wanted to just write it down and show you guys. Over 18 quadrillion, and then yeah. So can we start our today's topic? What is subnet, or what is subnetting? Subnetting is basically the process. Can we start today's topic? Please comment down yes if we can continue. Or if you guys have any doubts, please let me know. Drop your comments and we'll clear them all. Please drop yes, 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 and we'll start the next topic, that is subnetting. Divide large network into small network. Okay, Jayant, great. Continue, continue, continue. Okay, perfect, guys. Perfect, perfect, perfect. Total host of IP more 6. Wow, good. Dividing the big network process of dividing a large IP into smaller, more manageable subnetworks. Perfect recipe, perfect rap monster. Guys, just give me a second. I'll just have to pick this call. Okay, am I audible, guys? Please comment down yes, and we'll start the session. Subnetting is used, okay, to save IP. Yes, sir, yes, sir, yes, sir. Okay, so first of all, I'll give you a quite simple example. People here who don't know what subnetting is. Okay, so for example, this is our Bharat ka naksha, like map of Bharat. Okay, so this is a map of Bharat, and for example, there is a train which starts from J&K, Jammu and Kashmir. Then it goes like from J&K to Himachal Pradesh, then Punjab, then Haryana, then Rajasthan. Okay, and it ends in the Jaipur, Rajasthan. Okay, so we have five states here. Sorry, one, two, three, four, four states here. Okay. J&K, Himachal Pradesh, Punjab, Haryana, and Rajasthan. We clear with that? Now, I'll just give you a simple example here. For example, we have four. Okay, and there's a engine, train engine. This is a train engine. Okay, so this is a train, and which is connected with this. Okay, now we have how many states we have? It starts with, for example, okay, we'll cover it like this: HP, Punjab, Haryana, and Rajasthan. तीन चार ठीक है. So, for example, first state is HP. Alright, HP. Okay, you guys just understand the diagram थोड़ा सा खराब हो गया. No problem. First state is HP. Second one was Punjab. Third one was Haryana, Punjab. Third one was HR, and fourth one was RJ. Okay, Rajasthan. Okay. So we have five states here. First one is Himachal Pradesh, Punjab, Haryana, and Rajasthan. And this is a train which goes through these states. Okay. Now, the capacity here, and there's one thing that, for example, if you want to just your destination is Himachal Pradesh, so you just have to sit in this compartment or this coach of the train. And if you want to drop in the like if your destination is Punjab, then you just have to sit here, Haryana, then here, Rajasthan, then here. Okay. Now there is a sitting capacity. Okay. Yeah, from next time I'll do. I used to do that, but from next time I'll do the same thing. Today I didn't get the complete time to prepare the PPT. Okay. So here, the sitting capacity for Haryana, for Himachal Pradesh is 100 and Punjab for 100, Haryana for 100 and everyone has like basically 100 capacity. And now seats has been booked and people in Himachal Pradesh coach is 100, Punjab is 100, Haryana. Now, in Haryana, what happened? We have 150 people waiting here, and for Rajasthan, we just have 10 people. Okay, like 10 seats have been filled right now. Got it? Now, what happened here was, we actually have 150 people, like 50 people extra. So, what do you guys think? What can we do here to like to save the resources, like to save the environment, to save the resources of government? Okay, so what can we do here? Any idea? Any idea? We have 37 people here. Shift with Rajasthan. Okay, like we just shift the people of Haryana to Rajasthan coach. Okay, perfect. Perfect. Now, what we'll be doing here is we'll just shift 50 people from here to this coach because this coach is going empty, right? Make more shifts, right? Share HR with RJ. Okay. Now, the would say new schedule or new tickets or whatever it is. So, the new thing here is 100, and 60. Right, we have shared, we have transferred or we have shifted 50 extra people from Haryana's coach to Rajasthan coach just to save resources. Right, 100, and 60. Perfect. Okay, so two. This is the simple concept of subnetting, like to save the resources, to just limit or not limit but to just utilize the network to reduce the wastage. This thing helped us to utilize all the coaches to reduce the wastage. So there's a definition for the subnetting, that is a practice or practice of the practice of dividing. You just wrote 100 extra. Okay, dividing a network into two or more networks is called subnetting. Are we clear? Are we clear? Just please comment down where we understand now. You like all the 35 people here understand what is subnetting. We have a basic idea what is subnetting. Yes. We are clear. Very good. Very good. Now, I'll just give you one more example here. Not example, but we'll move further. Next topic we have. Uh, class A. Okay. Class A, for example, we have the IP. So I'll just write it down. Class A, we have 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So in total in class A we have around 16 million hosts. Now class B. In class B it goes like 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And in the first class A we have 8 bits, and in class B we have 16, and in class C we have 24. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And in this section, in class B, we have 65K hosts. And now, in the end, we'll be seeing class C. So in class C, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And the last one, 8. And in this last section, we have, for example, we'll just take every host here. Okay, we are not just reserving anything. Okay, so in total, we have these things here. Now, if you have a company, now just comment down your answers. If we have a company, a small company, I can say, or a startup, which like they basically wants or they have 500 computers. So which class should they choose? And keep this thing in mind that we guys don't have to just waste the resources. Okay, we just have to utilize the network completely. Class C, we have 500 hosts, मतलब 500 computers. But as some people said that class C will be used. So in class C we have 256 computers, right? Okay, can we do this thing? For example, can we do this thing? Can we just do this thing? We used 250 hosts from class C, and we just have remaining host and we'll use those from class B. What do you guys think? Can we do this thing? Then we shall borrow bits from the network chunk bits. If we use class B, then many of ours will be wasted. Correct. So we use class C two times. Okay, class C two times. Please comment down your views. What do you guys think? So we use two times. Yes, yes, yes. Anyone else? Class C. Can we do this thing? The example I just shared with you guys. Okay. So yeah, class C, so that we didn't waste the over 63K host. Class B is not the answer, I'm sure about it because it's gonna waste a lot of IPs. Okay. We can borrow some IPs. Okay. Now I'll just tell you the real thing. Anyone, we use class C, then borrow bits from the network chunk. Okay. Uh, do you guys agree with this guy? Borrow the network bits. And time pass boy, you agree with this person or with me? I'm saying that what I'll do here is I'll use 250 hosts from the class C, and for the remaining host, I'll borrow them from the next section or the remaining host we have in that section. So please just comment down that what do you guys think on this? I need everyone's POV here. We have around 43 people here. So please just write down what is your POV on this thing. Yes, yes, yes. Okay. Some people say yes, we can borrow. Some people say Rap Monster says yes, just like the train X, so we can in that way shift it. Okay. So the thing is, IP classes do not actually mix. The idea here, the idea here is like you just cannot take 256 source from class C and the remaining from class B. The thinking is basically classful, but the modern jo networking we have does not work like that. Right? What happens, like why those things do not mix? Because one network must come from another continuous IP block. Like you just cannot glue the class C and class B together. And we can say routers or subnet mask do not understand the mixed classes. Like if we have two uh, different IPs here on the same network, so it is quite like it they actually does not mix. So now, what is the right way here? Now, what is the right way here? So I can take, if you guys ask me, like the question would be, can I take from class C and then class B? Right, this was our question, and you would ask this thing that how how big how big a subnet do I need? Now, our scenario was around 500 usable IP addresses we just need and the minimum wastage. Okay, so for example, we just add a buffer here, buffer like thoda upar niche. So we need 500, but we'll add a buffer like 510. Okay, so we need 510 IPs. Okay, now we just have to find the closest power of 2. Power of 2, as we know that. Now, closest power of closest, if we just do this thing, the answer would be 254. We just have to do -2 because 2 bits are actually reserved. In every situation, you just have to do a -2 thing because every two or three, like for example, in class A, we have 2 bits being reserved, and in class B, sorry, in class A, we have 1 bit, in class B, 2 bit, and in class C, 3 bits. are being reserved, so you actually can't use that. Okay. Now, if I do just this thing, 2 to the power 8 and minus 2, you can just do minus 2 thing, right? Now, 254, and actually 254 is too small for our situation, right? So what I'll do here is 2 to the power 9, 2 to the power 9 minus 2, and there you go, 510. This is the perfect condition we can find, the closest power of 2. Okay, so now, so we just need 9 host bits. The power you can see here, 2 to the power 9, and this is the perfect number of IPs we need. So here you can see we need 9 host bits. Okay, now I can say the IP would be, now anyone can just tell me, we have 9 host bits, so what can we do here? Sir, can you repeat again? My Wi-Fi got disconnected. 254, 512 minus 2, 510. Borrowing will sure save a lot of IP addresses compared to using class B. Okay. Sir, we can also connect the computer, so two computer users can IP. Acha, uses one IP. Okay. Now we just need 9 host bits. So the real world example here would be, I'll just tell you. I'll just calculate the subnet size here. Okay, step 3 would be to calculate subnet size. Now, how can we calculate a subnet size? So we are actually using IP version 4. So total bits we have is 32, and host bits, the one we need, are 9, right? So network bits. We are just clear with this host and network thing, so we just don't have to use your brain here. Minus 9 is equals to 23, right? So subnet is slash 23. Now you just take slash 23 network. For example, would be 192.168.0 dot, sorry, 0.0 slash and 23, the subnet we are using. Now, what this thing or this example gives you, total IPs here would be 512, and usable IPs would be 510. So the range, like jo range we have is 192.168.0.1 to 192.168.1.250 224, not 24, 254. And the broadcast we have is 192.168.1.255, right? So basically you are not limited to the class C rule. So we have a thing called, this is called CIDR. The thing will be covering this thing too. Any of you guys have idea about the CIDR notation? Now, if you guys ask me, like some people told me that we can just combine those IPs with the previous example, the train example we took, right? So if I just give you a real world analogy, so it would be, you just think logically that you just don't combine two buildings to make one floor, right? You can't. You can't combine two buildings to make one floor. You just design one bigger floor properly, right? You just have to design a new floor or a bigger floor properly, right? So this is a basic understanding of this example. And now this is the basic understanding for the subnet mask. Okay, so subnet mask, what it does actually. So subnet mask tells us which part of IP is a network and which part of IP is host. It's that simple, right? For example, office, we have an office address. Okay, you guys go to office and we have an office address. So, name of the company name would be the network, and employee ID would be the host. Now, this subnet mask जो है that draws a line, ठीक है? And we are already done with this example. The example we have was uh, this one. For example, we take an example for 192.168.1.10, and subnet mask is 255.255.255.0. So now, can you guys just tell me what, like, how many number of hosts, or what are the number of hosts in this, and what are the number of networks? मेथड फॉर रिप अटेंडेंस फॉर्म कब शेयर होता है? कल मेरा मिस हो गया था क्लास लगाने के बाद भी। इन लास्ट अटेंडेंस क्लास 25 255 broadcast, a bit of it, yes, classless. Method for representing IP addresses in there. Three network, one host. Three network, one host. 24 host. ये क्या बोल रहे हो? Three network, one host. Perfect, guys. Three network and one host. There you go. It was that simple, right? Three network and one host. So we can just write it down that three networks and one host. Now, I'll just tell you what is CIDR. It is basically the easy way to say it. Just we can say that CIDR is just a short form of subnet mask. Instead of instead of saying instead of saying this thing, like this big thing, 255, 255, 255, we say slash 24, 24. Got it? Now because 24 bits are used for the network. Now, the example would be 192.168.1.0 slash 24. Basically, what happens here is, जो CIDR होता है, the CIDR thing here, the CIDR makes subnetting more flexible and more modern. So you just don't have to uh, tell this thing again and again and again. And this like slash 24, 25, 26. So we are already done with this calculation. How we got 23, 24, 25. How we got subnet. How we found subnet. Right. So it was that simple. And now the thing we know here is network ID. Any of you guys have an idea what is network ID? Any idea what is network ID? Also, yeah, I'll just mention two things. Broadcast ID. What is network ID and what is broadcast ID? And I'll just write it down if you guys haven't, like, if you have not understood any of these. So I'll just shout and like a real life summary. Okay. First thing was subnetting. Subnetting just organizes networks. Second thing was subnet mask. जो subnet mask है that decide the boundaries. Boundars. Now CIDR is basically the shorthand for the subnet mask. Next thing we have is network ID. So I just want to check the comments for the network ID and for broadcast ID. We have a whole calculation for that too. Yes, potato, yes. The first most host part of IP that identifies the network. It's like number of companies. Like if we take the same example of you, okay. The first most host IP address of a range is a network ID. Main connection ID is a network, and what's that? And the one who broadcasts it to the others have broadcast ID. Perfect. Broadcast ID, it communicates with the all host. Perfect. Now, I'll just now quickly write down the short forms here to make you understand. Network ID. What is network ID? So network ID is basically the first address of a subnet. The first address of a subnet, or we can say where the subnet starts. Network ID is where the subnet starts. Now, second thing was broadcast ID. So broadcast ID is basically the last address of subnet. Or as you guys have already told me that it is used to send message to all the devices, right? So broadcast ID is where the subnet ends. And this is like you guys all know this thing, right? So this is it for this session. And in next session we'll be covering I guess it will be on our Friday, next Friday. So we'll be covering those things. Any doubts or anything you would like to ask, and I'll just drop the attendance link, today's attendance link. Check the comments here. Subnet. Okay. So how was today's session? Sorry, I just didn't got time to make a PPT. And in next section, I'll create a good PPT for you guys to make the topic more easier, more understandable. Please, sir, bring the PPT. Okay, we lost topic today. We just wanted to cover the subnetting part. So, okay, session was good. Okay, so what I'll do here is I'll just create a PPT, and for the today's session, I'll just create a PPT for you guys, and I'll just drop the PPT, right? So, yeah, attendance link. I'll just share the attendance link. Before that, we have 36 people here. So I would like, look, I want that please like the stream. And after that, I'll just drop the attendance link. Dear session, enjoyed engaging. Thank you. Will appreciate. Okay, I'll just create a PPT today. Okay, we have 40 people, 30 likes. We are just shortage of 10 likes. Please just drop down the please just complete the target and I'll just drop the PPT here. Not PPT, I mean the attendance here. I'll just talk to the team for the PPT, not PPT, attendance. Just give me a second. Attendance. Okay, no problem. I'll still drop the PPT. Okay, so actually for today's session we don't have a link. No problem. Okay, so what we'll do here is we'll just drop the link in the comment section. We'll just drop the pin. We'll just pin the comment here, so you can just use that thing, or we'll just drop the link in the group. Okay, so you guys can just submit your attendance there. Perfect. Okay. Uh, Thank you for joining today's session. A very good night and bye bye. And yeah, networking takes time, brother. Yeah, we'll just you can just check tomorrow, like tomorrow after 9 p.m. You'll just get the link, so you can just do check that out. And thank you for joining today's session. A very good night to you, and bye bye. Sayonara.